Hi, this is Professor Huang. Today I will talk a little bit about this MRI magnetic detector and why we do it, kind of the background behind this technology. Okay, let's first take a look. This is a MRI machine, a big machine that usually is 2 Tesla or 3 Tesla. Has very, very strong magnetics. So if we see anything metal, ion metal, it will get sucked in there. Like this is a bed, that this is a oxygen tank. That's all gets stuck in there. Anything get a metal, and even this wheelchair, when it stuck in there, it kills people or injure people, and then you cannot pull it out because this magnet is so strong. If you really want to pull it, you need a crane uh, because the force behind it is like at 1 ton or 2 ton or like a 1,000 kilogram. So you need a probably more than 10 weight lift uh, pulled together. Champion, like a weightlifter champion, 10 down. Otherwise, you never get it out. If with these big guys, I think even you put a 10 strong man, you won't able to pull it at all. Because this is probably more than 2 tons. So the force goes proportional to the amount of metals in there. Okay, so how to prevent those injury? Well, small one like the pin, like a dental pin, uh, even a small dental pin, it can uh, kill the people. So how are we gonna do that? And the best way to do it is using um, detector. How the detector works actually. So this is the principle how the detector works. So if when the patient has nothing metal related, ion metal, like no cell phone, no pins, no dental pins, no heart surgery, no bone surgery, nothing metal, ion metal gets inserted in the body. And then this is a magnetic field of the earth is a straight. However, as long as you have a cell phone or have anything metal in the pocket, this thin ion metal will bend the Earth's magnetic field. When the magnetic field gets bent, there's a sensor. It's a magnetic angle sensor. So it sense angle change, it will alarm, sound an alarm. So this is a major principle. Um, Now let's look at how we're gonna build this machine. To build this machine, we will need an angle detector. Angle detector detect the magnetic field. Um, I have a team in California. We do autonomous car. So when you drive an autonomous car, you need the autonomous steering. So when you do autonomous steering, you need to find out the angle of steering wheel. How we do that? We have a magnetic field sensor. So this is a magnetic measuring a gear holding a magnetic. So this is steering. When you're driving, you're steering. So this wheel or this magnetic will spin. So when there's alpha spin, this guy will spin it per se. And then there's the element we call the AMR. So this AMR will sense the angle and then it will send it out. So that's how Paseo 1, Paseo 2, we put a two sensor there to make sure we got the autonomous car going right direction. So this is where we come from. So my team say, okay, if we can do autonomous car, we should be able to do the magnetic detector, as you can see, because here we put an angle detector or detect the angle change. The only difference is this time the angle change is really small because you have a dental pin. A change is like really small. So all we need to do is we make these AMR sensor more sensitive. So the one that's more sensitive we call it GMR, and then the one that's more sensitive than GMR is TMR. So by time we working on TMR, T means tunnel, magnetic resistor. So tunnel is based on the quantum theory, because this AMR is based on electron. So the electron is kind of turning around in the circuit or figure out, okay, how many degree our autonomous car has changed. Um, by the time we upgrade AMR to GMR, from GMR to TMR, the TMR works on a quantum level. So it's more than 20 times sensitive than like electron, because the quantum is a photon. Uh, it comes out of the electron. You probably need more than uh, 20 electron to make to kind of hold the one quantum, or you may or one electron hold many quantums. So quantum is very sensitive. It's just like a quantum computer is way better than the electronic computer. This is the technology behind it. So we're using TMR, which is using the quantum effect. When this electron spin, uh, the magnetic field change, the spin will change. The spin of will change, not just the electron current change. It's the direction of a spin of the electron itself. So it's sort of like you have a wheel and a wheel, and this wheel turns the electron direction from left to right. So it's extremely sensitive. It's more than 20 times accurate than the original, the one we driving this autonomous car. Besides that, because all the electron usually goes into a case, so you have to cover it. You cannot expose the sensor outside because if somebody spill coffee on it, the machine will die. So you need a cover. And where this cover come from? This cover comes from 5G. As you know, we're working on 5G so many years. So 5G antenna base station need a very good plastics or fiberglass. This kind of one kind of plastic. So we spend a lots of time. I have a team, obviously in Canada working on 5G, and then I have another manufacturing in China. So the we tried many formulas so for not only 5G plastic cover, but also for this detectors cover. Uh, why we need a good 5G cover? Because this cover will have to insulate the heat. So heat has to be insulated. However, the wave transmission has to be penetrated. How it works, it depends on conductivity. So the less conductivity, the better the uh, wave can pass through it. It's like because as I told you, the TMR works on the spin direction of electron. So if this cover has any metal on it, that's why when last time we visit Ericsson, I told everybody you cannot paint it because once you paint it, there's some metal going there. Once there's metal going there, the electron is kind of rolling around on the ground. And then the direction will messed up. So we want absolutely insulator. Well, at the same time, we need the heat doesn't go in. However, heat can go out. It's like gasoline tank. When we move in gasoline on the highway, we don't want the gasoline gets heated up by sunlight. At the same time, when the gasoline bumps, it create the heat. This heat has to go out. So this plastic cover is a highly complicated technology. You need to get the heat out. You don't want the heat goes in. You don't want it to be conductive. And also you don't want it blocks the magnetic field because the magnetic electron field are hand to hands together. So that's one technology. With these two technology, quantum uh, chips that is able to sense the angle, steering angle of the Earth. And also with this special formula, secret formula that able to let the signal go in and out. Why we need work, spend lots of time on it? Because the signal is a very weak, very weak. Why? Because it's only pin, like a 3 millimeter. The pin that the kind of screw inside the teeth or tooth or inside the heart, man-made heart, uh, or man-made spine, or man-made it like a leg bone or finger bone. So those things are tiny pins which generate the tiny signals. We need this signal penetrate the case. So we have a 5G technology in Ottawa. We have quantum technology in San Diego. And then also we have this manufacturer in China, Suzhou, the city right beside Shanghai. And then we are able to manufacture these a highly complicated machine. So this is the case we're talking about. We need always screw on the wall, and also we need to tie up the cover, make sure the dust, water won't go in there, and also make sure this angle detector is able to detect the tiny angle change of a magnetic field. Having said all those technology, uh, three places, uh, China, United States, Canada, and the final thing that our competitor did not spend enough time or did not fix the problem is when we install these pillows, like you can install one pillow on one side or two pillow on both sides. Obviously, two pillow is better than one pillow. However, the price will double or sort of double. The gate or the door of the MRI room sometimes face north, sometimes face south, sometimes face east, sometimes face west. We cannot ask a hospital say, hey, you put a door in the wrong side, you need to move your door. We cannot do that because they already had their door there. So we need to put those pillows on each side of the door usually. Um, then we realized because sometimes say this is the magnetic field of the earth. Say this hospital has the north, facing north, south. So magnetic field are gonna go like this. So if we put the sensor this way, we have two lines penetrated. So it's kind of good. However, if we put that way, it's only have a one penetrated. It's not good. But as I said, we don't know how the doors are facing. It may neither south nor south. So for example, this door is facing east west, and then you'll find if we put this way, yeah, we got a two. If we put this way, okay, we only get a one. So that problem comes because after we've tested in a couple of hospitals, we realize, oh, geez, this door is good facing. Oh, that door is not good facing. So we come up with the idea. We say, okay, let's do each pillow go different direction, or maybe with inside the pillow, like in here, we put a two direction. So we put a two direction, one this way, one the other way, appendix. Uh, that way we are able to uh, overcome the problem of the facing of the hospital doors or MRI room doors. So this way we are able to make sure uh, the doesn't matter any way you're facing, we are able to pick up the tiny signal using 5G plastic plus autonomous core Steven angle detector. Combine all these things together with the experience we gain from the hospital to deliver this final product that uh, works in any hospital, any door, MR gate facing any direction. It's sort of like our 5G. We want to talk anytime, any place for any long time. Usually, this pillow works whenever there's a patient that comes in, and doesn't matter what kind of metal they have, whether it's a small dental pin or whether they have a crane or wheelchair or oxygen tank. We want to detect them. So that's all about our technology usage and the route why we think about doing that. Our next generation uh, product after this, we're gonna build a stomach cancer detector still using this uh, magnetic angle detector, but with even more sensitivity. We call the picotesla. Using picotesla, right now we are between narrow Tesla and a picotesla. So our right now this detector is like a narrow to pico. The next generation will do pure pico Tesla detector, which is able to detect the stomach cancer. Because when the stomach has a cancer, the electron current stops there. When an electron current stops there, or the stomach is actually not moving. So the moving in different way. So the angle of magnetic field changes in different way. We are able to figure out the uh, stomach cancer. And the next generation product, we're gonna build a brain machine interface. Because when brain thinks, electron goes inside the brain neuron, and it will create a magnetic field. Still about the same thing like a picotesla. So we pick up those picotesla, we are able to figure out what's going on inside the brain, like what the patient was thinking or which part is wrong. And then we can using this uh, exactly the same quantum uh, chip, figure out the spin of electron inside the brain and the spin electron inside the detector to synchronize it to pick up a signal very weak. Obviously, we need probably more than 5G uh, plastic cover. We need a probably 6G plastic cover. With those 6G even better plastic cover, we're able to pick up a brain signal without open the brain, obviously. We just touch the head, we will able to pick up the signal. Okay, that's all for today. I'll stop here. Thank you.